For our final project, we created the classic arcade game of Snake using a Freedom board. We use the board's accelerometer as a controller to turn the snake in different directions. From the board, we take in the accelerometer data 3 times every second, which is about every zero point 0.3 seconds. This data is taken as an input into our C program that holds the game state. Almost all the work is done on the board at this time in C, except for the game output into a terminal, which is done through our Python program. The data from the accelerometer is processed and then given into the game portion of the C program, which interprets it into the game logic. The snake itself is represented as a linked list in C, and each of the snake sections are sent over to serial connection as XY coordinates of the Python program. The current fruit location is also sent over so that we can display the game with correct coordinates for both the snake and the fruit. At first, we tried outputting the game in the terminal through ASCII characters in C, but found it too slow, which was surprising and interesting to know, as we originally planned on doing the entire snake game in only C. Instead, we used the Python program to parse the data that is sent over the serial connection and then print it out on the terminal, displaying the entire game board with the snake, fruit, and boundaries. The game continues to update with every serial input for the user to see in real time.
For the game Snake, there are 4 directions the snake can move in. It can move up, right, down, and left. If no input is made, the snake continues moving forward. Collecting the fruit marked by the stars increases the snake's length by 1. Crashing into yourself or into a wall causes the game to end and the score to be displayed, which is related to the length of the snake. Pressing the reset button on the board restarts the game quickly.
We tested our game throughout the development process, adding one feature at a time and testing it before moving on to the next feature. We slowly built up the game in this way, first just displaying the board, then adding movement, growth, and so on. In testing, our largest difficulty came from memory management. Our initial attempt at movement involved creating a new section in the snake where it was moving and deleting the last section. However, we were running into hard fault errors after the snake moved around a dozen times because we were not properly freeing the memory associated with the deleted sections. We rewrote the logic to update the positions of the snake sections instead, and only add a new section when the snake grows. This bug was especially hard to find because it was not tied to a single line of code that we could easily identify. We used the example serial code for displaying the output of the board and many print statements to help debug and test. Some of our test cases include random strings in the same format that the board should output to check our Python display code, as well as playing the game and checking if the game ends when the snake runs into a wall or turns into itself.